Let's go over 0.5. So, yeah, I'm introducing you to the first formula you'll ever learn, right? And the first formula really is just pictured on the right hand side. It's V with a line over it, which I'm going to call bar. So it's V bar is equal to D over T. So what does a V mean, right? So this V means can either mean speed or velocity. And just like how you would measure speed or velocity in America, in the United States as miles per hour, we measure speed and velocity in science and in physics and pretty much the rest of the world in meters per second or kilometers per hour. Again, that bar over that V means average. D represents distance or displacement, which you learned in the previous topic, measured in meters. And T represents time. Now here's a caveat, right? So here's the thing. Actually, let me just not caveat, but here's the. Let me just take a picture of this. So when you're dealing with this formula, we learned last class that about scalars and vectors. So speed is a scalar quantity. Distance is a scalar quantity. So if the question is asking you for average speed, right? Let's say the question wants you to know, well, find me the average speed in this question. And since speed is a scalar quantity, then D must also be a scalar quantity. Right? D must also be a scalar quantity. And the scalar version of D is distance. So whenever your question is asking you solve for your average speed, well, then this D here means distance. That's something very important. And so let's solve for this question right here. So a group of bike riders took a 4-hour trip. During the first 3 hours, they traveled a total distance of 50 kilometers, but during the last hour, they traveled only 10 kilometers. What was the group's average speed for the entire trip? Now here, the question is asking for average speed. So they're looking for V bar. And since they're asking you for speed, you know that this D right here must mean distance. So the time, your total time of this trip is 4 hours. Well, what's your total distance? Your total distance is 50 kilometers. And then you travel another 10 kilometers, so that's 50 plus 10 gives you 60 kilometers. So you plug these into this formula. 60 is D and T is 4. And you get 15 kilometers per hour. So you get A there. B. So the question gives you one speed, right? So you have a one speed there, and then they give you another speed, right? So a car traveling on a straight road at 15 meters per second accelerates uniformly to a speed of 21 meters per second in 12 seconds. So that's my time. The total distance traveled by the car in this 12-second time interval is what? So they're looking for your total distance, right? That's what they want. So you want the total distance. You know that your total time here is 12 seconds. Well, what are we missing? We're missing average speed. Well, how do we get average speed? We're given two speeds here, right? We're giving one speed, which is 15. We're given the other speed, which is 21. Well, here's the thing. How do you calculate the average of two numbers? You add both those numbers and then you divide it by 2. So we're gonna add our two speeds here, 15 plus 21, and then we're going to divide it by 2, and this gives you 36. Divided by 2 gives you 18 meters per second, and so that's my average speed there. So we're plugging it into this formula. Right, average speed is 18 D over 12, right? T is time, times 12 on both sides, 216 meters is D. And this is my answer. Let's do this one. This is a slightly more difficult question. So a student on an amusement park ride moves in a circular path, radius 3.5. You have a time of 8.9 seconds. So you have a radius of 3.5 meters. Your time is 8.9 seconds. The student moves at an average speed of what? So your average speed again, you want d over t. We have our time. But what is the distance traveled in a circular path? The distance traveled in a circular path is your circumference. So this d right here is 2 pi r. That's the formula for circumference, 2 pi r. So we're going to do 2 pi r, the distance traveled in a circular path, over t. So 2 pi 3.5 over t, which is 8.9. And this gives you somewhere around 2.47 meters per second. And this is your answer. Let's move on. Now, on the other hand, if we're dealing with velocity, right? If we're dealing with velocity now, if the question is looking for velocity, well, this formula now, we know that velocity is a vector quantity. Well, how do you know? Because I say so right now. I'm labeling it as a vector. So velocity is a vector quantity, which means that this d right here must also be the vector version of d. The vector version of d is displacement. So whenever the question is asking you for average velocity, then this d right here will mean displacement. So let's do a practice question. So a car travels 90 meters north, right? So he travels 90 meters north, turns around 40 meters south in 15 seconds. No, rather, yeah. Then 40 meters south in 5 seconds. What is the magnitude of your average velocity? So you want to look for your velocity here. And they're saying that, well, the total time this took place was 20 seconds. You could have figured that out yourself, right? 15 plus 5. The thing you're missing here is d. But since the problem is asking you what is your average velocity, right? They want to know what your average velocity is. Well, we're actually looking for displacement. What is my displacement here, right? What is my displacement? I first traveled 90 meters north, then 40 meters south. Well, how far am I from where I started, right? Because that's the definition of displacement, how far you are from where you started. Well, I am 50 meters from where I started, and so my displacement here is 50 meters. So V bar is 50 over 20, and that gives me 2.5 meters per second is my average speed. All right, I kind of went through that really quick, but hopefully it was understandable.